Today we're going to talk about electron configuration. Electron configuration is a way that chemists can write out where an element's electrons will be. And this can tell us things about where the energy levels lie and also how an element will react if we do a chemical reaction. So, to start, we're going to talk about quantum numbers. Quantum numbers tell us about where an element is holding its electrons around its nucleus. The quantum numbers are n, l, m sub l, and m sub s. The quantum number n tells us about where the size of the orbital. And so as we go down the periodic table, we get more electrons and our orbitals get bigger. So as we go down, n gets bigger. So then we can move on to L. L is the shape of the orbital. And the shape of the orbital can be found based on where we're looking in the periodic table. So our possible shapes are S, P, D, and F. And on the periodic table, those are here, 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 and here. S, P, D, and F. So when we're making an electron configuration and we're filling in our electrons, we'll start here in S and we'll go S to P, and then S to D to P, and S to F to D to P. You'll see more about that later though. And then we have M sub L and M sub S. These help us know how many electrons fit in each orbital. This is also pretty intuitive from the periodic table because we have S, and S can hold 2 electrons. We can do that because S is when L equals 0, and that means that ML is 0, and it can be 1/2 or -1/2, and so it can hold 2 electrons since we only have one option here. But we can also just count. We can go up here to where S is and say 1, 2. And then we can go to where P is and count, and this is 6 across. So we know that P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. We can tell by counting 10 across here and 14 across there. So, those are the quantum numbers, and we use them to write out our electron configurations. Now, let's look at an example of an electron configuration. So this is the electron configuration for phosphorus, and phosphorus is right there. So, we know that these numbers are Rn, these numbers are Rl, and then these numbers up above are actually the number of electrons in each shell. So, when we're talking about those electrons, we just go across the periodic table and fill in each shell. So, for this example, what we would do is we'd start knowing that we're going to go all the way to phosphorus. So, we know it's got 15 electrons. So, we'll cross these 2 off, and we filled in 1s and got rid of 2 electrons. Then we'll fill in 2s and get rid of 2 electrons. And then we can come over here and we can fill in 2p, and we use all 6 of these electrons here. And then we'll go down to the third row of the periodic table and fill in 3s with 2 electrons, and then we're getting pretty close to phosphorus. So we'll use 1, 2, 3 electrons in the 3p shell, and that's how we find our electron configuration for phosphorus. Now let's try a slightly harder example. Let's look at arsenic, which we know has 33 electrons. So, to fill in arsenic, we'll start exactly the same as we did for phosphorus. So, we'll fill in our 1s with 2 electrons, and we can cross these out. Then we'll do 2s2, 2p6, 3s2, and then 3p6. So now we're all the way down here. We'll fill in 4s with 2 electrons, and then we need to go about filling in this row of the periodic table. So, should we use 3d or should we use 4d? Well, it would make sense that we would use 4d since we were right next to 4s. We're actually going to use 3d, and we'll fill in 3d with 10 electrons. And then we can just put the rest of the electrons in 4p, and we'll use 1, 2, 3 electrons. So this is the electron configuration for arsenic. But that raises the question, why is this row 3d when right next to it is 4s? And the answer for that is every electron fills with a different energy level. So if I were making an energy diagram down here, then my 3d energy would be lower than my 4p energy. So it would look like this. One second. It would look like that. And we do that because electrons will fill into the lowest energy orbital first. And so they'll fill into 4s first because 4s is lower energy than 3d. And you can just know going along that this right here is 3d. And then that this first f is going to be 4f. Alright guys, you should now know how to do some easier electron configurations. Best of luck.